Okay, so today we're going to use what we know about doing similar figures. Okay. Figures are figures that have the same shape but not necessarily the same size. So you can tell if these figures are proportional to each other by using the ideas of proportions. Okay, if they are similar figures, if you took the length of, let's say, ED, let's say it's 6, and the length of BA, which is 3, and you could figure out if they're proportional to each other. Now, we have to use this idea of corresponding sides. Corresponding sides is defined here. Corresponding sides of two or more similar polygons are in the same relative position. So essentially all it's saying is it's the same part of the triangle. So if you look at line segment ED, what is the corresponding side to ED? It's on the same part of the triangle, but on the smaller one. What would it be? Good. So we would say ED, it corresponds to BA. So if we set up a ratio for this, we would say ED's length is 6 and BA's length is 3. Now we can't tell anything yet because in order to determine if a triangle is similar to each other, or it could be a rectangle too, is you have to use another side. So let's say DF is 12. What side corresponds to DF? Good, AC, perfect. And let's say that that's 6. So DF's length is 12 and AC's length is 6. If you reduce these, 6 to 3 reduces to 2, right? 6 divided by 3 is 2. 12 to 6 reduces to 2 as well. Okay, because if you, it would be, let me show you how I do this really quick so you can see how. 12 and 6 share what factor? 6, right? So I'm going to go divide by 6, divide by 6. I get 2 over 1, which reduces to 2. Now, if you look at these two lengths, or these two ratios, can we say that those two ratios are proportional? Yes, because they are what to each other? They're the same, they're equal. So because the ratios are proportional, 2 equals 2, can we say triangle ABC is proportional or similar to triangle EFD? Yeah, this symbol right here is just a math symbol that means similar to. They're not the same size, but they are the same shape. That's what similar means, and it's defined here. Similar figures have the same shape, but not the same size. This symbol here means similar to. All right, so we talked about corresponding sides. It's like the side length that is in the same position on a big triangle as it is on the little triangle. When you're trying to figure out if they are proportional to each other or similar to, super important that you use the correct corresponding side. If you said DF corresponded to BA, what would happen? Would you get a proportional ratio? No, because you're not using the corresponding side that's in the same position on both triangles. So this is very, very, very important when you're doing today's work. The other thing that we're going to talk about is corresponding angles. Corresponding angles are this, it's the same idea. It's the angle that's in the same position on one triangle as it is on the other. What corresponds to angle A? Which one? Good, angle D. What corresponds to angle B? Angle E. What corresponds to angle F? C. Angle C. And the rule is if two triangles are similar, their angles are actually going to be congruent, which means the exact same. Even though this triangle, DEF, is larger than ABC, its angle measures are going to be the exact same to each other. So we know that angle A is going to be congruent to angle D, Angle B is going to be congruent to angle E, and angle F is going to be congruent to angle C. This symbol here kind of looks like what symbol? It looks like the similar symbol here, but it also has what symbol that we know? The equal sign. And does that make sense? If it's congruent, is it the same measure? Is it the equal to the other measure? Yes. So this symbol with the equal sign with the squiggly line over the top means congruent to. Congruent is a fancy word for equals, exactly equals. This symbol just means similar to. It's a different size, but it is the same shape. So that's what we're going to be talking about today. All right, look at this example. It says, tell whether the triangles are similar. The corresponding angles of the figures have equal measures. So if you look at angle F, what corresponds to angle F? Good. Are they the same measure? 34 degrees. See that? Same measure. Angle E, what corresponds? Are they the same measure? Yes. Angle D is angle Q. Are they the same measure? Yes. Okay, so because all of the angles that are corresponding to each other have the same measure, are these two triangles similar? Yes. The angles are the same to each other. The corresponding angles are. Let's talk about what side lengths correspond to each other. Let's see. I'm going to compare little to big. You have to do the same thing every time. If you're going to go little is going to be your first term and big's going to be your second term. Little triangle, big triangle. You need to write it like that. You need to put the little information on top and the big on the bottom. Okay, so what side on the big one, the big triangle, corresponds to DE? Good. What corresponds to, let's see, we did DE. What corresponds to FE? Good, SR does. And what corresponds to FD? Okay, now this is all easy and dandy because are they situated the same? Yeah, it's just like a slide over. Would this be more confusing if the big one was rotated? Yeah. Don't get confused. If it was rotated, you still need to pick the correct one, that if you rotated it back, it would still be the same part of the triangle. I'll see if I can find an example like that later to show you. What is the length of DE? 7 inches. What is the length of RQ? I'm going to reduce this. It becomes 1, 2, 3. Let's see, what did I erase? I erased FD corresponds to SQ. Okay. What is the length of FE? Good, 8 inches. 24 inches is what SR is. It reduces to 1 to 3. Length of FD is? Length of SQ?
36.
Reduce it. What do you notice? Yeah, all your side lengths are proportional to each other. So you would say there's 2 proofs to triangles being similar to each other. First thing you talk about is the angles. The second thing you talk about is your sides. So you would say, yes, triangle EFD is similar to, hang on, I'm going to use my symbol, triangle RSQ, because you need to talk about 2 things. Because the corresponding angles are what to each other? Good, yes. Can I use congruent?
Yeah.
Corresponding angles congruent are congruent. Your writing would actually be nicer than mine, but it's messy on here. It's hard to write. So triangle EFD is similar to triangle RSQ because the corresponding angles are congruent. and the corresponding sides are what? To each other. They're not the same length, but are they proportional? Yes, that's the word that we mean. They're not the same size, but they are proportional to each other. So the corresponding sides are proportional. Okay, so that is proof that those two triangles are similar to each other. So we use these two pieces of information, sides and angles. It says with triangles, if the corresponding side lengths are all proportional, then the corresponding angles must have the equal measures. With figures that have 4 or more sides, if the corresponding side lengths are all proportional, then the corresponding angles may or may not have equal measure. Okay, and let me show you why. I have 2 rectangles and then I have a parallelogram. We're going to see if they are proportional to each other. It tells us right here that rectangle ABCD is proportional to QRST, but ABCD is not similar to WXYZ. And this is how it works. Let's talk about side. Let's go AB corresponds to what length? So we take it off of this one. So let's look at this one. See how those two lines correspond to each other? QR, which is 8 to 10, which simplifies to divide by 2, divide by 2. What corresponds to BC? RS. I'm only comparing these two right now. BC is 4, RS 5. What corresponds to CD? Good, TS, which is also 8 to 10, which goes 4 to 5. We know that these two, if it's a true rectangle, we know that the opposite side lengths are the same. So those two should be like the same, right? Because we're still working with 8 to 10, which means that the other two should come out to be what? 4 to 5? And is it? Yep. AD to QT? 4 to 5. Good. Now, all the sides are proportional, therefore those two rectangles are what to each other? They're similar, not congruent, because congruent would mean the exact same copy. Are they the exact same copy? Or is one a little bigger than the other? Right, but they are similar because they're proportional. Now if we check ABCD to this one, AB to WX is going to be 8 to 10, right? BC corresponds to XY, which is 4 to 5. Then if we did this length to this length, that's also 8 to 10, and AD to WZ is 5. Now, the side lengths are proportional to each other, but are those two figures similar? Because the angle is not the same. Remember, in order for something to be similar, it has to be the same shape, just a different size. Are these two the same shape? No. We have a rectangle and we have a parallelogram. They are not the exact same. Therefore, they are not similar. The angle measures are not the same. Do you see how these two angles here are obtuse? They are equal to each other. And these two angle measures are acute, which are equal to each other. On a parallelogram, this is true. The opposite angles are the same measure. Do you see how those two are the same? And then do you see how those two are the same? Okay, but they are different to each other when I'm comparing angle W with angle Z. That's not true for a rectangle. They are the same 90 degrees. Right. Okay. We have a quadrilateral. It's a trapezoid, because I only have one set of parallel lines. We're going to determine if they are similar to each other. if you look at this, it says the corresponding angles of the figures have equal measures. Angle G corresponds to angle N. Are they the same? Yes. Angle H, 2. Are they the same? Okay. Angle E, L. Are they the same? Good, 45 degrees. And angle F to angle M. Are they the same? Okay, so according to the angles, they have equal measures. Now let's take the ratio of the corresponding sides. They did big to little, so I'm going to go line segment EF corresponds to what? Good, ML or LM. I'm going to do LM because do you see how I started with EF? I'm going to start with LM. That's 15 to what? 6? Good. Simplify. What do they share? 3. Divide by 3, divide by 3. What corresponds to FG? MN, which is 10 to 4. Divide by 2, divide by 2. So far it's looking good, right? Can I just stop here though? No, you need to keep going. Check it all the way around. Because this is not a rectangle, so the side lengths, it doesn't follow that rule of opposite side lengths are the same. GH is, NO is, divide by 2, divide by 2. EH corresponds with LO, 20 to 8. I can divide by 4. Divide by 4. What do we find out here? Yes, so we say the ratios are all the same. Therefore, quadrilateral FGEH is similar to quadrilateral MNLO. Okay, so here it's just talking about how you determine whether the ratios are proportional. So what they're doing is they set up all the corresponding sides and they're wondering, question marks, if they're proportional. Is 15 to 6, 10 to 4, 10 to 4, and 20 to 8 proportional? Once you reduce them, what do you find out? They are. They are all proportional. In simplest form, they all equal 5 to 2. The hardest part about this, you guys know how to do ratios, you know how to do simplest form, that stuff's all stuff you know how to do. The hardest part is making sure that you use corresponding side lengths. If you pick the wrong corresponding side length, it will be wrong. Okay? Make sure that they are in the same position. If one of them is rotated, do not get confused. If you need to, trace it, rotate it so that it's sitting in the same place as the one that you're comparing it to.